Hello. We're ready to start.
Sweet.
Cool. Okay, firstly, thanks very much, everyone who's here and everyone in the stream. Thank you for joining. We are Internet. My name's Chris. I'm business development. I'm leading up this business development, and this is Greg, our lead developer. What is our vision? Our vision is for liquidity to flow freely across any blockchain without sacrificing decentralization. Our first mission to achieve this starts with Bitcoin. It's a $1 trillion market, which is dominated by centralized exchanges, so it's the logical first starting point. We'll be doing this with Kintsugi on Kusama and Interlay on Polkadot. Why does all this matter? Why should you care about any of these things? Let me explain by going back to the 12th century. In 1211, the Mongolian army, led by Genghis Khan, wanted to overthrow the Jin dynasty. His idea to do this was do something that no one else had done ever before: breach the Great Wall of China. They eventually found a weak point, a secret tunnel made by the Jin army as a means of escape from the Wuxia fortress. By exploiting this, they were able to take over the fortress and attack China directly. This is the first time anyone had achieved this in the history of the whole war. 5 years later, they did it 2 separate times with 2 other fortresses and led to the downfall of the Jin dynasty, which led China since the 10th century. 21,000 kilometers of wall, 2,700 years of work by over 1 million workers, rendered useless because of 3 centralized gates that were able to be exploited by a few smart people. As of today, $14 billion of Bitcoin is in the DeFi area. This is great. It brings in liquidity and momentum into the area, but there are 2 key trade-offs happening when this is happening. 1, every bridge is either fully centralized or at best distributed. So to use your Bitcoin in the DeFi area, you have to trade off one of the central doctrines of Bitcoin in the first place. It's decentralization. Secondly, you take up more risk, and in most cases, you are fully uninsured or only insured by Ethereum. If any of these centralized entities act badly or are compromised, billions of dollars worth of Bitcoin goes to zero. We think this is a big risk, and this is why Interlay exists. We are the only fully decentralized bridge that allows anyone to mint, anyone to facilitate minting, and upon minting, interBTC is fully insured by multi-collateral insurance. We are to Bitcoin what multi-collateral DAI is to the US dollar. We allow you to take your Bitcoin into the DeFi area, pay, trade, lend, borrow, invest, and earn yield, while being able to redeem at any point you want, and being safe in the knowledge that if anyone breaks the rules, they will be slashed and you'll be reimbursed 110% of your investment, enforced by the protocol, not by us. Quick look at our tokenomics. We will have 10 million Kint on Kusama and 1 billion Inter on Polkadot. This will be distributed to communities, 70%, which will be 30% Vault, 10% crowd loans, 25% treasury, and the rest will be for the foundation and to the Interlay team. The remaining 5% will be for stake to vote rewards. After this 4-year period, we'll have a 2% inflation after that. Where are we now, and where are we planning to go in the future? Kintsugi is already live. We're onboarding KBTC vaults in February. If you want more information, please come at me after the talk, and I'll be happy to give you more information. If all goes well with the crowd loan, we should be doing the exact same with Interlay and interBTC in April, while building out DeFi partnerships in the Polkadot ecosystem. In Q3, Q4, we'll be adding more collateral earning models. We'll be experimenting in Kusama with things like synthetics, NFTs, stablecoins, and taking the learnings and success stories from that into Interlay and into BTC. In 2023, it's expansion into Ethereum, Cosmos, Solana, and integration with other underlyings like Bitcoin Cash, Doge, CBDCs, and other things that the community think are interesting. I'll now pass over to Greg to go a bit more into detail about the technical aspects of the interlay and interBTC.
Thanks, Chris. So we're built on Polkadot. If you attended the Substrate seminar yesterday, you'll have learned just how ingrained in our nature Polkadot is. We're built on Rust and Substrate, and this allows some pretty cool stuff. So first and foremost, Rust is a brilliant type-safe language, but because we work with Rust, we can also integrate with some of the Bitcoin libraries. So we natively use the SecP256K1 lib. It's fully vetted, audited, battle-tested, and enables us to integrate that and focus on other core security issues. With Substrate, we can do some cool things like custom transaction fees. In Ethereum, you might be aware of TBTC, the other sort of competitor to us, and they're kind of tied to the Ethereum gas model. So submit block headers, the cost of that scales linearly. Whereas we can afford to cheapen transactions for relayers, for example, or even make them free if they abide by the rules of the protocol. Lastly, we have some off-chain workers, and we use that for liquidations. And when I come on to the Vault registry, I'll explain a bit more how that works. The full stack is audited and peer-reviewed. At our core, we're quite academic. The protocol is based on Xplain. Our founders, Alexi and Dom from Imperial College London, described this in the Xplain paper a few years ago, which was published by IEEE. Since then, the company itself has published over 30 papers and garnered around 700 citations. Code has been audited by two companies, Informal Systems and NCC, and passed both audits so far. We're currently undergoing a third round of audit with another company. The initial interBTC prototype was supported by Parity, or Web3 Foundation rather, and since then we've maintained a good working relationship with them, and we're part of the Substrate Builders program. All code is fully open source, as is the true nature of the D-Web. So what is interBTC? It's a one-to-one backed asset, fully fungible, backed one-to-one with Bitcoin. There are a few simple steps we'd like to highlight and how the process works. Initially, we start with locking your Bitcoin with a custodian. We call these custodians vaults. Anyone can become the vault, as Chris said. You can also run your own vault, register your own identity, and mint your own interBTC. Once the Bitcoin has been sent on the Bitcoin side, we can then mint the interBTC asset, one-to-one with the locked BTC, subject to fees. And then you have access to the wealth of opportunity in the BTC DeFi ecosystem, particularly on Kusama and Polkadot. And you can use your then interBTC as collateral in other lending protocols and yield on it and do some other interesting things. Lastly, when you're ready to exit your position, we allow redeeming one-to-one, and we have some failure handling, which I'll discuss a bit more in detail soon, to ensure that users are always protected. So I'd like to start with the Bitcoin relay. This is the core kind of logic of our parachain, and everything else is kind of built around it. So we have an embedded SPV-like client. This is used to verify the proof of work details of the Bitcoin chain, as well as handle fork handling. And we also determine difficulty adjustments, and so we can also ensure that the Bitcoin blocks received by off-chain relayers are valid according to the logic of the Bitcoin chain. We're zooming in a bit here. We can see that for each block, a couple of important details to note. We have the parent hash of the previous block, so we always know what the chain is building on. And then we have the Merkle root. For this, we can then use to verify transaction inclusion with a Merkle proof. Zooming in even further for that transaction, and we'll see what's important later, we have a couple of things worth noting. So for a transaction, we have inputs and outputs on the Bitcoin side. So the script sig will detail who's spending their coins, and the output, which would detail the script pub key, who the coins are being spent to. And we also sometimes include another kind of output called op return. And this is for replay protection. On the interBTC parachain, in some of our request formats, we generate random kind of IDs, and these are to be included in the return values of Bitcoin transactions to ensure that the Bitcoin transactions are always fresh. That is, malicious participants cannot replay duplicate transactions in order to mint fake interBTC. Which now brings me to the issue protocol. So, as I mentioned, we have vault custodians. They are over-collateralized participants in the system that are designed to hold Bitcoin. Before we can issue anything, we must have the vault lock collateral. So on Kintsugi, this will be KSM initially, and on the Interlay network, that would be DOT. But vaults do support multi-collateral, so we'll be adding more assets as time evolves. Once the vault has locked collateral, it's then up to the user to submit a request to issue interBTC, and they can then transfer Bitcoin to the vault on the Bitcoin network. Lastly, once the user has sent the BTC, they can use transaction inclusion proof, as just shown, and show that the interBTC parachain that the transaction was included on the Bitcoin side. They send the BTC, we can now mint interBTC, and they receive that directly into their account and in the free balance. So one thing to note, so I mentioned before we have a sort of notion of replay protection. With one thing we've learned in kind of some of our prototyping phases is users often send the wrong amount of Bitcoin in the issue process. This is due to wallet support or other user error. One common reason for this is some wallets show balances in micro BTC instead of BTC instead of normal BTC. So we developed. I think that's so replay protection in OKD. The reason actually we support that is because wallets don't support adding additional transaction outputs. In the URI format, for example, we only have the address field and the amount. So users can only send to an address and amount, and we can't detail this random ID that we would have generated on chain. So we developed an in-house scheme called on-chain key derivation, which I'll go into in a second, and that ensures that vault addresses are generated at random and entirely unique, and that itself makes the transaction unique. Before other comments, so before the user can request issuance, they provide briefing collateral, and this is kind of like a spam protection mechanism. So when they hold the vault's collateral in earnest, then they have to provide the briefing collateral, and if the user does not send Bitcoin, they would then be slashed within around 24 hours. So this is a parameter we have on chain that says the vault can then basically respond and say the user reserved my collateral but never sent me any Bitcoin. So I'm now, in effect, I can now claim their briefing collateral, and that's sort of an incentive for vaults. And as mentioned, vaults must be over collateralized around 150% to be secure. So I just mentioned the on-chain key derivation scheme. So it's a pretty unique technology we offer. There's a little bit of maths involved, but the scheme itself is based on stealth addresses, which you may be familiar with if you've been in the Bitcoin ecosystem at all. So the scheme works like this. Vaults register on-chain, providing a public key, V. A user then submits an issue request. So part of the issue process is two-phase commit. They generate the issue ID. We can then use simple elliptic math to determine a new point, D, and this is the deposit public key. On-chain, we can then do some simple calculations to derive the address that the user would have to send the Bitcoin to. And off-chain, the vault can then do some more elliptic math and determine the secret key for D. And that ensures that the address is completely random, generated whenever an issue request is made, but the vault can always retain access to the signing key. So I kind of accidentally went a bit into user failsafe discussion before, but essentially when one of the issues we found in one of the early testers was, again, people could send the wrong amounts of interBTC on issuance. And we derived a couple of additional protocols to account for that. So there's two possible like flows here. So underpayment, a user sends too little into BTC. So we would still allow that to be minted on execute in the second part of the two-phase commit. But we would slash an equivalent amount of their griefing collateral to say you've still reserved some of the vault's collateral to mint this into BTC, but you know, you should still get your interBTC at the end of the day because the vault now holds physical Bitcoin. The other issue could be overpayment. So you send too much Bitcoin when you're meant to send a lesser amount. So we would, if the vault is sufficiently collateralized, that is, they have more collateral that can back the amount over 150%, we would still mint that into BTC because, of course, that's good for the ecosystem. But if the vault doesn't have a sufficient collateralized position to account for that, we would only mint the original amount and create what we would call a refund request. When the refund request is created, this is submitted on-chain, and then this would allow the vault to map and send BTC to the user in order to get some rewards. It's important to note the vault doesn't actually have to send any Bitcoin back. This is only an incentivized action because it was ultimately user error. So we discussed issue, refund, and now I'm going to discuss redeem in a bit of detail. So the redeem process, as mentioned, the user wants to burn their interBTC and they want their physical Bitcoin back for whatever reason. So they start a redeem request. The vault, monitoring the interBTC parachain, will receive this request and transact with Bitcoin network off-chain to transfer that Bitcoin. Once that has been included in the Bitcoin network with sufficient confirmations, they can then submit another SPV proof on the interBTC parachain, and that would unlock the collateral that was reserved to cover that interBTC. And they can then withdraw that position, so they could that we would basically call that reserved, and they could then unreserve that collateral, or they could use that to back additional interBTC. So if users were to submit additional issue requests. Like with issue, we have around 24 hours for the vault to transfer the Bitcoin. So this is measured in sort of parachain blocks, and if the vault fails to send that Bitcoin, we can do then one of two things. Side note here, before I go into what we can do there, is the replay protection here is the op return scheme you mentioned before. The redeem requests generate a unique ID on each on the first part of the two-phase commit for the redeem process, and that value should be included in the op return. The reason we still have like the op return scheme here instead of the on-chain key derivation is because vault clients are advanced technologies that are implemented. We have a client implemented in Rust, which I'll discuss in a bit. But they have full access to the customizability of their transactions, so they can easily add additional outputs in the output of a Bitcoin transaction, unlike a user who, for example, if they were using the Bitcoin URI scheme, would only have access to the address and the amount. So yeah, what happens if the vault fails to send Bitcoin? So we call this cancellation. The user can then trigger a cancellation on the interBTC parachain. They can retry. So they basically say, okay, I still want to get my physical Bitcoin back. I'm going to retry with another vault. And it's a Boolean, and they say, yep, I want to retry. We would then slash a punishment fee. This is around 10% of the redeem value, and this is for, obviously, time lost. The other thing they could do instead is say, you know what, I just want money back. I'm going to reimburse. So because the vault is over-collateralized, we can burn the equivalent amount of collateral, and in addition, we slash a punishment fee. So the user is, they get a reward for that. Lastly, we also ban the vault from participating in anything other activities for around 24 hours, again measured in parachain blocks. This is because the vault client software may be offline for whatever reason. You may have shut down their server, and the vault may no longer be online to process requests. So this is as much a failsafe for other users as it is for the vault itself to ensure they're not additionally slashed. The last kind of core protocol in the sort of issuance model, I would call it, is replace. And this is how two vaults can basically exchange Bitcoin. Well, effectively, a vault would want to exit the system using the replace protocol. So we have the notion of an old vault and a new vault, so just two vaults in the system. I'm going to start with the old vault here, and they would submit a replace request on the interBTC parachain. A new vault would come online and say, hey, you want to exit the system, I want to lock more into BTC because I want more rewards, or the reason would probably be they want more rewards. So the new vault would come and say, I have more collateral that I can cut back this Bitcoin, I'll lock more and take your place. So an old vault, they may have any amount of in this replace request. But if they wanted to exit the system, they would request their entire holdings, for example. The old vault will then transfer Bitcoin as with issue and redeem, and they have 24 hours to do this. And then once we are able to prove that on chain, they can then unlock their collateral and withdraw their position from the system. Again, we use op return for replay protection because the vault client software has greater access to customizability. And we also have proof and collateral. So I talked a little bit about collateralization and amounts. But we do rely upon one trusted component in our system, which can be fed by decentralized untrusted components. So there's a few examples here. We have ongoing relations with Band and Chainlink, and we also run oracles ourselves. But the oracle subsystem maps collateral positions to collateral prices to Bitcoin. So for example, if we wanted the exchange rate for KSM BTC, which is say maybe 2,000 KSM per Bitcoin, they would submit that exchange rate on chain. Due to the fact we allow multiple oracles, we do aggregate the exchange rate, and this provides some stability. So as I mentioned, one of the things they can submit is exchange rates from Bitcoin to the supported collateral asset. The other thing I kind of glossed over in some of the protocols there was Bitcoin fee estimates. So we have transaction fees on our side, of course, but on Bitcoin, we also have transaction fees, and it would be amiss to not account for that in our model. So the oracle also allows trusted accounts to submit Bitcoin fee exchange rates. And this is used in sort of redeem and replace to detract from the request amount in order to ensure that the vault has enough to pay for fees as well. So this is subtracted from the request amount. And this nicely brings me to the vault registry. So vault registry is another component we interact primarily with the Bitcoin relay and the oracle. It does a wide range of things, but as I mentioned before, it allows registration of vault identities to collateralized positions. The vaults submit their public key, for instance, and then we can also allow them to withdraw and deposit more collateral to ensure that they stay over-collateralized. A bit more detail here. So vaults in the vault registry have an identity. So this is comprised of a few things. We have the substrate account ID, so that's their main account, their sign, which they sign with. But we then distinguish based on the collateral ID and the wrapped ID. So an example here is KSM KBTC. The wrapped ID is likely to be stable across, at least for a while, until we introduce other underlying assets, as Chris mentioned, such as Bitcoin Cash or Doge. So on Kintsugi, for instance, that will always be KBTC. But since we support multi-collateral, the collateral ID will change. So we may have KSM and KBTC, or maybe even liquid KSM and KBTC. And that allows us to distinguish different collateralized positions of that vault. As mentioned, we have the Bitcoin public key. And for all addresses, we also map all addresses in the system for theft reporting. And I'll discuss this just in a few slides. I also brought up before the notion of off-chain workers. So this is a feature that Substrate offers, and it allows us to submit unsigned transactions from validators in accordance with the protocol. And here we liquidate under-collateralized vaults. So any vaults whose position, according to the Oracle, has fallen below roughly 110%, again, subject to which collateral asset it refers. But if it discovers that position is under-collateralized, we'll then liquidate that vault's holdings and hold them in the system. We can also do we also have a cool kind of scalable reward distribution algorithm, which does constant time distribution of rewards. Chris is going to discuss shortly a bit more about the rewards. But here we can then track how much rewards a vault would receive based on the amount of locked BTC they have. So I think I've mentioned quite a few times collateralization, but like, what really is it? How do we go from an exchange rate, some Bitcoin or interBTC, and a threshold to a collateralization level? There's a bit of fairly simple maths here, but we can see here, in order for a vault with an exchange rate of 2,308 KSM per BTC, in order to be secure over the secure collateral threshold, and if they have an issuance of 1 BTC, so they either have, say they have 0.5 issued and 0.5 that are currently in the process of being issued, we would then require 3,462 KSM in order for that vault to be securely collateralized. Ideally, you'd want to probably be over the secure collateral threshold in order to kind of hold against exchange rate fluctuations. But that is the bare minimum. Secure collateral threshold is the bare minimum you would need in order to be able to issue Bitcoin. And as I mentioned, roughly 110%, for example, for liquidation. So we can then do some calculations and see when that would fall under that. We can also do the reverse here. So we can say, okay, I have 3,400 locked and 1 Bitcoin issued, and do some reverse math and see, okay, I'm 150% collateralized. Through the Vault Registry, we also do some kind of handling. So interBTC is issued. We require that vaults don't move Bitcoin except in accordance with the protocol. And in order to secure that, we have the notion of fraud proofs. Again, these rely on SPV. But for various requests, we can determine if the vault processed that transaction in Bitcoin in accordance with our protocol, or if it was just sending Bitcoin somewhere else that's out of protocol. And if this is the case, then we would liquidate that vault. So it's a pretty heinous act, I guess you could say. And this is incentivized action, so there are rewards. We take roughly, I think, 5% of the collateral liquidated up to a maximum of 0.1 Bitcoin at the current exchange rate. Another cool thing to mention is nomination. So vaults don't have to provide the collateral by themselves. We have any users can nominate collateral to a trusted vault, and they would earn a proportional share of rewards. In the future, we aim to have vaults set some sort of percentage which they would give to nominators, but currently the share is distributed proportionally. Which brings me now to like vaults, and I'm going to hand back over to Chris for this.
Thank you. So vaults allow us to fully insure our users and have a decentralized bridge. If you wanted to take part in reclaiming decentralized Bitcoin and DeFi, what do you need? What do you need to know, and how do we reward you for your value? Firstly, you need the capital to put up collateral. Every vault needs to be over collateralized to lock BTC. Secondly, this BTC needs to be stored somewhere in a wallet or otherwise. And thirdly, you need to be online for redeem requests. These need to be fulfilled within 24 hours. So we recommend that vaults are online at once every 8 hours just to stay on top of this. Also, you need to make sure that your collateralization rate stays above 110%. If your collateralization rate goes below 110% or you do not redeem within 24 hours, you'll be automatically liquidated and the users will be reimbursed automatically. What do you get for these responsibilities? What are the rewards? First and foremostly, the tokens. We have 30% of our total supply going to vaults to bootstrap the system and reward them for the value that they give. Second, third, and fourth are less so, but will grow as the network grows. These are the minting and redeeming fees of interBTC, protocol enforcement, so reporting theft and replacing underperforming vaults, and thirdly, yield generating assets. So you could go into Karura, stake your KSM or DOT, get the derivative L.LKSM, and put that as collateral for a vault so you can earn in that DeFi protocol. So instead of your assets being in one place, earning one thing, you can put them as collateral for a vault, earn our native token, interBTC from minting, collateral from other vaults, and yield generating assets from other DeFi protocols. This is distributed over a 4-year model that incentivizes newer vaults rather than the older vaults. So the rewards will be larger in the first year and taper off as the network grows and the other ways of earning increase. The way in which this is done is the percentage of BTC that you have locked compared to the BTC totally locked by all vaults is the percentage of these rewards that you get. Pass back over to Greg to explain.
Thanks. So we've covered quite a bit about what is the vault, what responsibilities they have, but we haven't really defined how a vault goes about this. Vaults are an off-chain client, ultimately. You can think something similar to keepers in MakerDAO. They respond to on-chain actions and transact with the Bitcoin network. So, for example, we can see here that the vault would perhaps would relay Bitcoin blocks, but then when it monitors issue and redeem requests on the interBTC Parachain, it would then process that off-chain and submit transactions to the Bitcoin network. Zooming in a bit here, we use some technology. So first thing to mention, obviously, is we have two connections. So the Vault client maps between Bitcoin and interBTC. On the interBTC side, we use the JSON RPC and SubXT libraries, for which we have contributed to. And then on the Bitcoin side, we just use some low-level communication there and some of the Bitcoin libraries, including, as mentioned before, the SecD256K1 lib in order to generate the deposit keys. To liken what Chris just mentioned about the earnings, so from a functional perspective, we have specific things that the Vault client does. For collateral, it can deposit and withdraw the supported assets, and this is basically used to ensure that the Vault is never liquidated. So it monitors incoming exchange rates and responds to those by depositing more collateral and then sometimes withdrawing its position as well. Is that?
Sorry about that.
Okay. Oh, hope that didn't mess up the live stream too much.
I think it was like good.
Okay, cool. Yep, so we also have issue requests. As mentioned, we have the OKD scheme. So off-chain, they have to calculate new deposit signing keys and add those to the Bitcoin wallet in order to be able to spend that Bitcoin in later redeem transactions. Redeem requests, so we transfer the Bitcoin for any redeem requests incoming. And lastly, as mentioned a few times, we have some actions which correspond to the Bitcoin network. So we monitor incoming blocks, fetch the block header, serialize that, and submit it to the interBTC Parachain. We then monitor transactions for theft. So I had a few sort of process diagrams here of how the Vault client works at a low level. So firstly, we kind of connect to Bitcoin, make sure that that's fully synced, because we also want an up-to-date view in order to transfer that view to the interBTC parachain. We then use, as mentioned, subXT to connect to the interBTC parachain, download metadata, make sure that we're speaking to the right version that the client is built against. It will then go ahead and import keys from issue requests. It will also do this on an ongoing basis and calculate new keys to add to the wallet. And lastly, it will execute requests. So, for example, issue requests are executed on the best effort basis, and execute its own redeem requests, its own refund requests, and its own replace requests. For the relay, what it will do is monitor incoming blocks, as mentioned. It will verify which exact block header needs to be included based on the current view of the BTC parachain. So it will use some logic to determine if because there could be multiple forks on the interBTC parachain, block headers may be stored, but on a different branch, and it will use some internal logic to calculate exactly what block header needs to be submitted based on the view of the Bitcoin network. Lastly, for theft, what the vault will also do in order to get some theft fees, it will it will stream transactions incoming over the Bitcoin network. So this includes all transactions, it will iterate basically through every transaction in every block. We'll fetch active vaults from the interBTC parachain. So we're asked the parachain for all the vaults that are currently active holding Bitcoin and what their corresponding Bitcoin addresses are. And for each transaction, we'll then investigate, we'll say, is the vault featuring an input to this transaction? If it is, does the output correspond to something determined by our protocol? So is this vault transferring Bitcoin for a redeem or replace request? If it's not, and then the address isn't registered, so if it isn't, so we also allow merge transactions, so vaults can obviously conglomerate their assets into fewer addresses. And if the vault is not doing that and it's spending Bitcoin elsewhere, that's when we would then go to the parachain and say, hey, I think this vault is misbehaving. Let's slash it. Here's the proof. And I'll have a reward for that. Thank you. So yeah, let's go. You took the.
So, spoke about the token a lot. It's one of the main ways that we bootstrap the system. So why should you care about it? Why should you want to hold it? Firstly, governance. As we build up partnerships with DeFi ecosystems and with other vaults, our token becomes more integral to their business. So they'll drive up demand so that they can take part in more of our business decisions. 5% of the supply goes to staking rewards, and you can increase your capital efficiency by using our native token in the transaction fees. These are the things that make it a sustainable token and the one that people want to use. But what are we doing to increase the utility and value over time? Our vision for vaults is for them to be their own decentralized bank. We want them to be able to increase collateral and lock it in a collaborative way, and once locked, use it dynamically. Firstly, we're doing this we have already a system in place in which vaults can trustlessly borrow from the on-chain treasury and from people who want to add liquidity to the vault and share the rewards gained. Secondly, we want, once the collateral is locked and the value is within the vault, we want vaults to be able to use it in a dynamic way. So we're building automated market makers and decentralized exchanges so you can trade your collateral with others and use it in a strategic and dynamic way rather than it being locked and forgotten. Back to Greg.
And what else can we do with this token? So as most parachains, we also invoke governance. So this enables us to evolve the protocol over time in response to user demands. It's important to note, especially for Kintsugi, we're 100% decentralized. We as Interlay do not control any component. We help develop, but the community is now fully in control. Also with the governance token, so this would be Kint on Kintsugi or Inter on Interlay, they can then use what we would call vote escrow tokens. So they would lock up their governance token in order to earn staking rewards and receive a sort of virtual balance that they can then use in our governance module. The governance module itself, or the palette, should I say, is a fork of the substrate palette, democracy palette, but it's been redesigned somewhat to be a little bit different from Polkadot, and specifically for optimistic governance. So some key differences between Polkadot is that all proposals in our kind of governance system are public, so there's no council. The council cannot push anything through. Everything is up to users. These proposals are then accepted by default. The terminology for that is supermajority against, but what that effectively means is that public proposals will always pass without significant contradiction. We also have a technical committee like Polkadot. Unlike Polkadot, the technical committee cannot veto anything. It can only fast track. So I have some parameters here which is worth noting. So on Kintsugi, we have a launch period of around 7 days. This means that new proposals are taken into voting every 7 days as referenda. The voting period then lasts 7 days, and afterwards will be shortly enacted. So this would be through a runtime upgrade, forkless, and that would upgrade the logic of the chain. If it was fast-tracked, it would be around 3 hours. The reason we still kept fast-track proposals is because there will be critical bugs as we evolve. We know we're only human, we make mistakes in implementation. And fast-track voting will allow us to quickly process any security-critical bugs and upgrade the logic. So that's kind of like, I think, all the core parts of the chain and token models that you should be aware of. I hope if you have any questions, I'm going to be hanging about. Me and Chris will be hanging about afterwards. Feel free to come up to us. So we prepared a short workshop, which I will now go into. And this is basically just showing you how easy it is to get up and running with a vault. So there's very little requirements. If you have Linux, that we find, I think we build all our vault clients for Linux. But if you have a powerful enough computer, you can obviously build it for other distributions. So the workshop is revolved around just 3 simple things: install the vault client, connect to our testnet, and build. So I'm going to gloss quickly over these instructions. We can come back to them in a second. But what I did want to mention is kind of our challenges here. So we have some prizes for anyone who wants to build some cool stuff on our technology. We'll initially, after we set up the vault, then you should have everything locally that you need to develop against. And we have some examples here of what we think would be cool to build and the corresponding kind of prize pool for that.
What's the name of Discord?
Interlay. If you go to interlay.io, they should have a about page, and you can find the link to our Discord and join through there. Yeah, we can add that info after. And we'll follow up on Discord as well with the exact details of the challenge and the prizes again. I'd also like to mention a few things before I kind of go back to the instructions. Interlay, the interBTC Parachain on Kintsugi and Interlay has treasuries. So we're very invested in funding new work and new ideas. So beyond the prizes mentioned before, if you have something cool that you'd like to build, feel free to submit treasury proposals. And those will be voted on by the governance we just discussed. And lastly, we have a bug bounty as well. So this is something funded by Interlay. So we have some, obviously, some designations of critical severity, and these will have different corresponding prizes, which we'll address on a incoming basis. And I think that's everything we had to say. We're now, as I said, we're hanging about for a bit, answering any questions. If you want to get stuck in and play around with the vault client, or if you have questions, feel free to flag us and we'll answer that. I'd just like to say thank you again for your being here and listening to us ramble for a while. It's been fun, and yeah, thank you.
Thank you.